Welcome everybody online. As a member of the JMP academic team, I know that many professors embrace the teaching materials we are offering for free. For some of them, it's even a reason to choose JMP for teaching. And we are very proud of our resources developed over the last 15 years, and I'm glad to present them to you today. Besides a welcome and a very short introduction to JMP and a wrap-up, of course, we will see how JMP supports teaching basic concepts and statistical methods, self-paced learning and problem solving. And second, we will suggest also some core elements to take your courses online. So today we will talk about teaching and learning, two sides of the same coin. We will address the teacher's needs, but also consider the learner's experience. Other webinars on JMP, the software, are showing that it is easy to use with powerful scripting, state-of-the-art analytics, all very visual, interactive, and fun. But today we talk 90% about teaching content, bringing the software to life. And by teaching, we are not limited to the lecture room because, fortunately, SAS and JMP supported distance learning in many ways for a long time. In the past, we already saw more and more professors combining in-person and online teaching into a hybrid, so-called blended learning approach. Or they used a flipped classroom. Students watching lectures outside of class and taking homework and activities, the fun part, in class. Given the ongoing circumstances of COVID-19, many teachers are even forced to take their courses online. Stay tuned and see how JMP can help you on that journey. Being an engineer myself, for today I've chosen applications and examples which I consider being relevant for the engineer and the scientist of tomorrow. So this session is for you if you ask yourself questions like, how can I speed up course development, teach statistical thinking more efficiently, engage my students even more, and focus on the relevant skills needed for solving problems in industry. So later this week, we will share the session recording and also this journal on the left in our academic webinar library. The journal is a JMP file, by the way. You can also open in the 30 days trial version of JMP. By the way, you can also read about this topic in our recent blog series with 6 episodes. On jmp.com, choose Community, then JMP Blogs, and search for teaching. If you are new to JMP, watch JMP for engineering in 60 seconds on YouTube. A very short but very nice video. You can also follow these links here to learn more about JMP applications and also customer stories from industry. Let me just give you a very quick demo of JMP, looking at 90 batches from a tablet production process. So here we see 90 batches in 90 rows. This data set has 21 variables in 21 columns. We have some stored scripts, and this data set is about a manufacturing process. And it's about defects on dissolution. And what does it mean? Dissolution, that's our KPI, our response variable here. And there's a property that there are some nodes telling a bit more about this response variable, but you also see that there is already a spec limit set, and this is a lower limit. Dissolution is a percentage, so that's the percentage of tablets in one batch dissolving in water within 1 hour. And this should be higher than 70. Higher than 70%, which is our lower spec limit set on our response variable. So let us see how good we are doing right now. So for that I take the graph builder and look for my response column, which is dissolution, and I drop the y on the y-axis on this graph, and we see a dot plot. And if I also add our binary response, we see that we have two categories here. One is accept in green and reject in red. So, is there any relationship between our response dissolution and maybe mill time, which is one of the settings in our process? So I can drag and drop mill time, one of our axes, and drop it on the x-axis for this graph, and we get a scatter plot. We still see the lower spec limit, and we get a smoother on this relationship. So here I can fit the smoother more or less to our data. I can even add a confidence band to this smoother, or I can switch to a fitted line. And now we see a linear line, a regression line for this bivariate relationship. Another question, is this the same relationship for different screen sizes? So mill time is a continuous setting, but screen size is a categorical setting. It's ordinal, that's the green symbol here, but it's categorical. So by moving this and moving it over other drop zones, I can create this graph, or I can color by screen size. So here we see we have 3 screen sizes, 3, 4, and 5. Or I can have all 3 in one graph. I release the mouse button, and that's maybe something interesting, because here we see that the relationships are not the same for all screen sizes. So this tells me about an interaction. So it means that the relationship between our response and one setting depends on another setting, which is screen size in this example. I can also take screen size again and replace the continuous X by a categorical X, and now we see the dots in 3 different groups for our screen sizes, and I switch this to box plots. And the question is this the same distribution, the same summary of our data if we choose different sugar suppliers? So this one comes in, the sugar supplier, and again I can drop it here or here, and then we have the box plots, but separated by sugar supplier. There's one batch shown here which could be an outlier, so it's shown as an individual data point, and this maybe needs some further investigation. When I'm done, you click done, and your graph is done. Okay, so here's a script, distributions, and these are the distributions for many of our variables. And using this output, where we see both distributions of continuous variables like mill time, where we have a histogram and we also have a box plot attached, and categorical variables like API particle size, small, medium, and large, where we have this bar chart. And also our lot acceptance is shown as a bar chart in this example. So now I can also select data and explore the subset of data with high mill time. And we see that for high mill time batches, so tablets produced at high mill time settings, we are not doing bad. So this looks pretty good. I can also select reject and accept. And you see that also the corresponding batches are also selected in the underlying data set. Yes, and I can select the rejected ones with the red row markers. And now I can also explore the process settings, and I see, oh, we have a lot of higher screen size settings here. Maybe that's causing a problem. What else? We are working at higher blend time. Maybe that's causing problems. And I can look at all the variables in here. There's not just one variable explaining everything, of course, but I get some hints. I can also, from the Analyze menu, choose Distribution and just look at our response dissolution. Yeah, now I get the same report, but just for a single variable for dissolution. Let me turn this around so we have enough space here to do this. And we get the histogram and box plot and also the lower spec limit. I collapse some summary statistics, and JMP notifies that we have a spec limit set on this variable. So we may be interested in the capability of our process, and for that we get automatically this process capability output as well, where we see this similar graph here, but also the short-term and long-term capability indices, the CPKs and PPKs, and also statistics about non-conformance. So we have, at the moment, we have around 15% of defects in our data set. Yeah, on the context menu, the red triangle, I find more options, and one of them is an interactive capability plot. So this is quite nice just to play around. So here I can change the location of our data or the spread of our data and see how this would affect our capability. I can also change and play with the spec limit itself and see how this changes a lot. Another script, one way, that's a bivariate analysis. So here we look at dissolution again by screen size, and on the red triangle I can ask for an analysis of variance which shows significance. So this tells me there are some differences between the means of these groups, and we also have the comparison circles which show me where these differences are by color. So here we see that screen size 5 has a significantly different mean compared to screen sizes 3 or 4, which are both in red. Next step could be a multivariate analysis using the multivariate platform. So here we look into correlations, basically. We get a pairwise scatter plot matrix where we can look at the scatter plots and relationships. Also nice to find hints for outliers, and we get a color map on correlations. And if we want to reduce dimensionality in our data set, we can go directly into a principal component and also factor analysis from here. A parallel plot is another nice way to look at our data and explore the data supported by the dynamic connectivity in our plots. Partitioning, that's a nice way to build an explanatory model and learn about our data. So here we are partitioning the data and try to get the highest difference in lot acceptance. So what is really telling us a lot about lot acceptance? So for this, I'm building a classification tree here, and we get this output, and this tells us that this is a good path. So if screen size is not 5 and spray rate below 404, you seem to be all green, all accepted batches. So going down this way here would give us all red batches, all rejected. So that's a nice way to explore the data as well. So we get a model, but it's also very nice for understanding what's going on. So here we have a ranking of predictors explaining a lot in this data set. We already looked at capability. Another topic on process monitoring and process optimization is stability. How stable is your process? And the typical tool to use here is a control chart. And JMP has a control chart builder, which is as nice as the graph builder just for control charts. So here I take the variable dissolution and just drop it on the control chart. And we get everything automatically. So we see the control limits calculated by JMP together with the lower spec limit. And the red ones, these are the control limits plus minus 3 sigma intervals for the individual measurements. And here, if I right click, I can also activate warnings, maybe running all the tests. And there was one issue at this point here, so number 5. So this was a test which indicated that there could be some special cause, a problem, not just random variation, but something special going on. So this would suggest some further investigation. Control charts, very easy to create in JMP. And a last example here, building a model finally. So after understanding our data, we could build a model, and this model was built using the Fit model platform in this way. So we have this continuous dissolution response, and we already identified some important model effects. So we have 6 main effects and 3 interactions in this model here. And then by clicking run, we get to this report. So here we have a first diagnostic plot, the actual by predicted response data. We have an R-squared of 73%. And then the summary. And here we see screen size is most significant. And then spray rate and mill time and so on. This interaction at the bottom, blend time times spray rate, is not significant. So we can also remove it from our model to make it easier to understand, easier to explain. Compressor also not significant. So now all the p-values are small. So this seems to be a reasonable model, hopefully a useful model. So, and by collapsing the other outputs, we are just looking at the profiler now. And here we see the linear relationships of our continuous effects, except for one categorical factor, which is screen size. And for spray rate, we see that the higher spray rate, the lower the dissolution will be. So that's bad. So we should be at low spray rate maybe, but oops, what's that? So by changing one factor, this relationship of another factor changes. So that's an interaction we can also see on the profiler. So it's not that easy to find the best settings, but no worries, JMP can help us here. So there's a desirability telling us the higher the better. And now I can ask JMP to optimize, find the best settings. And according to JMP, this is the highest dissolution we can get by these settings down here according to this model, of course. Yeah, and if you want to deploy this model somewhere else, I can also ask JMP, hey, give me the scoring code, maybe as C code, and then I can take this and implement the model somewhere else, or I can also deploy it as Python code or also other scoring codes. Okay, so by this we saw that for students it means learning from data is really easy, very efficient, and it can also be fun. Yeah, it's very visual, it's very interactive. And by the way, what I used here for my short demo is JMP Pro. And JMP Pro is included in all academic site licenses called JMP Academic Suite. Now, let's have a look at our resources. And I would like to start with resources supporting us teaching basic statistical concepts. Yeah, and this is quite important. So every engineer should understand these concepts. First of all, variability and also uncertainty. And the first example here for resources are our interactive teaching modules. And they let students experience concepts like analysis of variance or confidence intervals. Where to find them? On the help menu, sample data, and then open teaching scripts and you find the teaching modules. So here's one example, demonstrate ANOVA. So I change the group means, so I make
okay,
them...
I'm sorry to interrupt. Maybe there is a mobile phone not far from the microphone. But it is really doing some
Okay.
noise now. Thanks.
Sorry for this.
Sorry.
I hope it's better now.
Yes, definitely yes, thanks.
Okay, I'm changing the group means for this example, for this sample here, and then I can show the group means also visually. I just changed, but I can ask JMP for a standard ANOVA analysis, but I can also ask for other information, for instance, the power of this test. So here with this test, we get a power, which means a probability of 89% to detect, to confirm a difference if there is a difference. And that's quite important. Yeah, another teaching module is about confidence intervals for the population mean. So here we have the population characteristics and we see the mean is 100. I also use 100 samples and I activate animation and now I draw the samples and you see the confidence level was set to 95%. What does that mean? A confidence level of 95%. Yeah, it means that we can accept around 95% of green intervals. The green intervals are the intervals here which include the true mean, the population mean. The other ones, not including 100, this is the population mean we typically don't know. Yeah, we have to estimate, and the red ones are not including the population mean. And that's typically 100% minus the confidence level. So just these examples here. We also have calculators and simulators. Some other tools also very nice for teaching. And just one example here. So we have the the calculators and the simulators. One simulator is about experiencing the central limit theorem. So here I just add some rows, and because the columns have formulas, so the values are automatically calculated by these formulas here, and it uses a uniform distribution and then calculating the means at different sample sizes. And now I can take this into a distribution analysis. Just look at the histograms for all of these 5 variables. And now we see that with an increasing sample size, it gets more and more to a normally distributed output here on the right hand side. Maybe it's a good idea to use uniform scaling. I can also take the grabber tool here and then make the bin size smaller, so for a better comparison. I could even fit a normal distribution to all my histograms, and we see that we get a pretty good fit for a sample size of 100. So these were tools, interactive teaching modules, calculators, demonstrators, simulations you can access on the sample data index. Some other nice tools are directly built into JMP, and they are just one click away in JMP Pro, I have to say. And that's bootstrapping, so a very nice way of resampling for testing sampling distributions, and also randomization or permutation testing, so an easy to use resampling method for testing empirical significance. And for that I use this sample data set here and just open one of the analyses reports. So this is an analysis of covariance, and don't worry about any of these results, but I'm now interested in the confidence interval and the significance for these estimates here. So these estimates here. How to get this? So first I need to prepare the data set, because we need to reshuffle this categorical variable, and that's quite easy. So I just add a new formula column. I choose random, sample with replacement. And now the polymer column is resampled as the resampled version. And I will use that one now. So as I said, it's just one click away. So I can right click and then you find Bootstrap and Simulate. And Simulate, that's the permutation testing option. So here I switch polymer out of the analysis and I switch the resampled version of polymer in. And I do this maybe 100 times. So this is happening now. It takes a few seconds. 80 of 100, almost done. And then we get this result data set with the stored script, the distribution, and I can just run this distribution script. And the red line, that was the observed statistic, the observed value. In this case, the estimate for this pH parameter. Yeah, and we also see this down here. So we have the confidence intervals at different alpha levels, and we also get empirical significance on the right hand side. This is called permutation testing or randomization testing. A nice way to look into significance for different types of statistics where you don't have a corresponding output in your report, or where it cannot be calculated by any formulas. So you need something tricky like this method here. Next section, this is about statistical methods. So the tools I showed you so far, these are different concepts, smaller concepts. Now combining different concepts into certain methods, how is this supported? And what I would like to show you where to go is this shortcut here. We call this our resources portal, and you can reach this by jump.com/teach. And many of the resource types we will mention soon can be accessed by this portal here, jump.com/teach. And the first type I would like to mention, that's our learning library. So this is the section here, and if I click on that one, or if you choose jump.com/learn to get to the learning library, you get to this page. And what I suggest is, especially as a teacher, but also for students, it's really, really useful, download the whole bundle of one-page guides. And this gives you more than 100, or I think around 100 one-page guides. And let me go to the first page. So this is the latest version from end of last year. And here you see the topics. And the question is always, how can I do this in JMP? And there's a bonus track at the beginning, some pages about, where can you find platforms supporting you to answer certain questions. So typical questions you ask when you look at a single variable, when you look at relationships between two variables, or even many factors, multivariate analyses. So this is unsupervised learning, exploring patterns and features, and also collecting data and design of experiments. And the typical guides look like these here. So this is just a single page, in this case a classification tree. It tells you what is it, just one sentence, and then how to do this in JMP, step by step, using sample data, and also how to interpret the output, and maybe some additional tips and tricks and some notes where to find further information. The learning library with our one-page guides. Another section you can also find on our portal is about advanced placement, AP statistics courses. So also supporting quite basic exercises, introducing basic introductory concepts in statistics. So they can also be used with the student edition of JMP. They are also good for secondary schools. And again, you can download the whole set of exercises, so all lab activities and also the solutions. And there's also another resource center with more information on the community. This is called AP Stats Resources, or our lab activities. These are some basic activities, so they are not that complex. Let me go back to our portal, this one, because here you also have access to even more activities in complete courses. And these courses are shared with you from SAS Education. So if you look at the course material library, you also find on the resource portal. And then look up instructor access only materials. You get access to the trainer kits or instructor materials from SAS for almost 20 courses now. So there are even some more than you see here. But many interesting courses also for engineering, so including statistical process control, measurement system analysis, design of experiments. And here you see the topics, for instance, which are covered by this DOE course on custom or optimal designs. And this is a 2-day course, so it needs 2 days to teach the whole course with all the exercises and everything. But as an instructor for non-commercial use, you get all the slides, all the exercises. So let me show you this here. So these are the instructor notes, which are for the instructor, and they tell you how to teach this course, all the topics, the agenda, and then it starts here. So here you have all the slides, but also the explanations, what's important here, how to present them, and there are also exercises, all step by step, how to do this, how to show this in JMP. There are also student exercises introduced by this document here. And what the trainer uses in class is a JMP journal like this one here. So this guides the trainer through all the chapters of this course, all the topics. So this course is the custom DOE course. So it's an introductory chapter and then experiments with 1 factor starting really, really small, 1 categorical factor, then 1 continuous factor, and so on. Then experiments with 2 factors, and then expanding all these sections. So they lead you to demos and simulations and also exercises like this one here. So that's for practicing a data set, and then there are many scripts you can follow and then make the model, run it, and you get to this profiler for this example. And here we also see a quadratic relationship for x2. So all the training material is available for free, including all the PowerPoint slides. So typically you don't take the full course, but just a few demos, exercises, and ideas. And this should be very helpful, so you will never start on a green field developing a new course. The next is about self-paced learning and practicing. And this became very popular in online teaching this year. And the first I want to talk about is Stips and also Skip. So these two. So Stips, this is our online course, Statistical Thinking for Industrial Problem Solving. So these are 7 modules, and I think all of them are relevant for engineers. Some of them are really, really relevant and also closing gaps and providing some really relevant skills which are needed for problem solving in industry today. So our industry customers really ask for these skills here. So for instance, the quality methods course teaching about measurement systems analysis, control charts, capability analysis, but also the DOE course. So that's this module here. So again, you see the topics. It takes a student a few hours working through all the topics, but there are many videos, short videos, exercises, demos in JMP. And there's also some practicing, and for that, the learner does not need to have JMP installed on a local machine because JMP Pro is provided in the cloud for this course. So there are 7 modules here. All of them come with a short quiz at the end. And if a student passes the final quiz, they also get a digital badge or certificate that they passed this module. And there's also an overall certification you can take at a SAS training center or elsewhere to certify for all these modules here. And Skip is the little brother of Stips, and that's our statistics knowledge portal. And this has been created to provide some less technical but really motivating and inspiring content. Yeah, so if you look at simple linear regression, so here you can really understand the concepts and look at some animations and graphs. And this is talking about correlation, for instance. Yeah, really nice introduction of the basic concepts. That's the statistics knowledge portal. Also online, available for free. Next are also courses from SAS Education, but these are e-courses, e-learning courses the students can take, maybe to prepare for a class or later to dig deeper to learn about other topics, or maybe used also during a class, somehow as a blended learning approach. The good news here is that all these courses, which can be found again, so if we look at the portal again, Course Material Library, there's a tab Online Courses. This is the one which gives you information about these e-courses from JMP Education, and if you click here you see which courses are available, and all of these are available with unlimited access for all your students for free, just with an academic site license of JMP. And if you're interested how to use this, how to access these courses for your students, please check with us and we will help you and send you the instructions. Webinars, we already saw our academic webinar library, so we have live webinars like these, but also many recorded webinars, these academic webinars in our library. Just check them out. There are also ones for just getting started with JMP, but also special topics like the scientific workflow and automation of JMP, customization, how to teach DOE and health and life sciences and more. These are our webinars, and of course there are also many options for books. And just to give you two recommendations, the first one is called Problem Solving for New Engineers, what every engineering manager wants to know, from Melissa Bowie. And this is a great book. It talks a lot about the most important concepts, and that's variability, uncertainty, and design of experiments and experimentations, how to collect data for the best way, the most efficient and effective way to learn from your data, from an engineering perspective, of course. And the second, this is called Visual Six Sigma, Making Data Analysis Lean. This book has a short introduction to Six Sigma and also to JMP, but it has 6 very engaging case studies. And they are real projects, Six Sigma projects, trying to improve, to understand a process, but also to improve a process, of course. Real life projects, nice examples, a nice storyboard, and all the storytelling from typical Six Sigma projects. And also, problems like, we don't see anything in our data. What's going on? And then, maybe a measurement system analysis helps to show that most of the variation in your data is coming from the measurement process. So that should be fixed first, and then you have to understand the process. Where's the variation coming from? From different operators or measurement systems, instruments, or what's going on. So all of this is discussed, also including some experimental designs by this book, and you can also download all the case studies and data sets you need if you want to use these examples in teaching from our website. So these are books. There are more books. Just follow the link here. And you can also request free book copies from SAS Press Books. And there's a form online you can also find by this link here. The last section is about the real stuff, the fun part, solving real world problems. And here we provide a case study library with many real world problems. So really, for practitioners who should apply their knowledge and experience to answer a question, to solve a problem, to find defects, and that can be found again on our portal. Below Learning Library you see Case Study Library, and here you see all the different case studies. There's one on defect sampling, for instance. It's this one here, and you can download the data set for all these cases, and also a PDF which introduces you to the problem. You get some background information about the company and what's the problem at hand. And then what's the task? What should we solve? What do we need to investigate? And here's the data set. And then there's a sample solution with all the steps. And at the end, we discuss what did we learn from a statistician's point of view, from the managers, the business point of view, but also from the JMP user's point of view. So these are the case studies for JMP. There are more cases from books. I mentioned this Visual Six Sigma book, which has great case studies, even more complex ones than in our case study library. And there are also other books like the Optimal Design of Experiments book from Hoos and Jones, and Building Better Models with JMP Pro book. All of them come with examples you can download from internet pages and use in teaching as well. Or you may want to work with industry partners directly and arrange maybe internships or joint research projects. So that's up to you, but we are really happy to help you building these bridges and bringing you all together, academia with our industry customers and partners, and then help you to really teach the relevant skills and prepare the students for their later workspace. So these were all the resources I wanted to mention today. The second topic is about which ones to use if you have to teach online. And for that we have again another blog post you can also find on the JMP blog. Just search for online instruction or online teaching and you will find this one, and this introduces some key components, and these key components are the ones down here. So the first step, the first level is really how to get your students started. So one option is to send them to these introductory videos from importing data into JMP, doing some cleanup and exploratory analysis to finally share or publish the results. So all these videos take less than 30 minutes, but they really provide a driver's license for JMP to your students. So they are even more options. So on the help menu, also the tutorials are very nice. You can ask your students also to have a look here. So there's a tutorial, for instance, on DOE. So this introduces you to all the steps. Why DOE? What about a response? How to specify a factor? Then why should we think about a model now? And this is discussed. Then how many runs can we afford? And then on the design and so on. So this is a nice step-by-step tutorial just for DOE. And there's also a welcome kit. So on the help menu, if you look at JMP on the web, you also find a JMP welcome kit, which is a nice engaging tutorial, which is also online and introduces new users to JMP. There's of course the full documentation, which is also taken online with the latest version of JMP. Just go to jmp.com/help and you will find the online help. The next level is, okay, so now I understood how to master the software and how to use it. So now how can I do this or this in JMP? And then it's time for the one-page guides again, the learning library. So that's really the go-to resource for students starting with JMP. By the way, you can also look here if you just need some yellow pages where to find something in JMP. So if you want to do some partitioning maybe, go here, predictive modeling partition. Yeah, so the search is also really helpful, and there's also statistics index, many other tools which help you to guide you to the analysis which is most useful for a certain problem. Third level, exercises and assignments, some real problems. And here the case study comes in, or any other cases. And it could be quite nice if you ask students to publish their findings, maybe on JMP Public, which is an online site where students can publish and share results, and they can also discuss them online. And then the highest level, so to say, is a full course, and here I just mentioned the statistical thinking course again, an online course. It's not just a how-to, not just an exercise. These are really foundational, very basic and relevant skills and modules from our online course. And we see many professors who do really good things, like they also deploy their course on a learning management system, and then they link all the courses and all the students to certain resources and tasks and quizzes and so on. So that could be a nice idea. Now, or why not let the students teach and present? So that could be a lot of fun, and the students would also learn how to present new topics to the class. It's definitely a nice experience. So we also did this with several universities, and it was always a great session. Or invite other speakers, maybe from industry, or guest speakers, or even from JMP. Or add some gamification to your course and the learning path. Of course, you don't have to do this, but it could maybe inspire you to take your course to a next level. Okay, summing up. So we also have a new webpage about doctoral training, and this is a new offering called JMP Academic Suite for doctoral training in sciences and engineering, especially in chemical engineering, also pharma and biotech. And this also includes the delivery of a full 2-day DOE course, including all the train-the-trainer support and sharing all the material. So this is a full program for teaching PhD students, and this was developed together with Imperial College in London, and we make this available to other universities now. So if you're interested, go to jump.com/doctoral training. Just summing up, you can go back to this one here. If you say, so much is available, where should I start? So definitely check out the sample data, the learning library and case study library. Look at the course material library. So this one here, course material library. And if you plan to teach maybe design of experiments, so this page shows you all the relevant one-page guides and videos, the webinars, books, add-ins, and e-learning courses and other resources which would be helpful for this type of course, in this case for teaching DOE. Then e-learning courses, the trainer kits from SAS Education and Stips. This gets a lot of great feedback all the time. So definitely check it out and ask your students what they think. I think they will be quite excited about this engaging and entertaining learning experience. Yeah, as a reminder, so all of this is discussed in our blog series you find on the JUMP blog. Yeah, please stay in touch with us. So we are updating the resources all the time. But if you have any special requests, or if you want to provide your own content and work with us on case studies, please get in touch. Yeah, and if you are moving from Excel or SPSS or Minitab or other software to JUMP, we really make this easy. We have a lot of migration kits and supporting information and material to make this a smooth experience and show you the benefits of JUMP compared to other solutions. Also check out the JUMP community, which is really helpful to discuss your questions or share opinions with other JUMP users worldwide. And if you want to stay updated in the future about new seminars and new webinars like this one here, please visit jump.com/opt-in and provide your email address, and then you will get invitations to these events like this one. So that's the end of this webinar. I hope you found it useful. We are always happy to hear from you, what you think, what you need. Please contact us, visit our webpage, or send us an email at academic@jump.com.